Dear students, in this video we will deal with the topic how to find the oxidation number of an atom in a molecule. So first we will discuss the rules for determining the oxidation number of an atom in a molecule. Number first is oxidation number of all the elements in their elementary or uncombined state is 0. Like hydrogen in hydrogen molecule, neon, nitrogen in nitrogen molecule, phosphorus in phosphorus molecule, sulfur in sulfur molecule, and likewise oxygen in O2, fluorine in F2, all are having oxidation number 0. If they are in elemental state or they are single atoms in uncombined state, they will have the oxidation number as 0. Next point is oxidation number of an element in their monoatomic ions is equal to the charge present on that particular ion. Suppose Na is denoted by symbol Na positive, so here the oxidation number of sodium will be +1. Why? Because it is a monoatomic ion plus the ion is having +1 charge on it, so the same will be the oxidation number. Here tin is having 4 charge on it, so it will have same oxidation number. Chlorine is having -1 charge, so -1 oxidation number, and sulfur is having -2 charge. Likewise sulfur will have -2 oxidation number. In this way, if there is any monoatomic ion, the charge present on that will give you the oxidation number. Next is oxidation number of fluorine in all its compounds without any exception is -1. Oxidation number of group 1A elements like sodium, potassium, rubidium, cesium and francium and lithium will have oxidation number +1. Oxidation number of group 2A elements, that is beryllium, magnesium, calcium, strontium, barium and radium, will have oxidation number +2 in all their compounds. Oxidation number of hydrogen in all the compounds will be +1 except hydrides, in which their oxidation number will be -1. Oxidation number of oxygen in almost all its compounds will be -2, but again there are certain exceptions. In peroxides like hydrogen peroxide, barium peroxide, sodium peroxide, they will have oxidation number -1. And in other compounds like superoxides and suboxides, according to the compound, the oxidation number may vary. And if oxygen is in turn attached to a more electronegative atom like fluorine in OF2 and O2F2, then their oxidation number will be respectively +2 and +1. So these are the 4 variations of oxidation number in a variety of compounds, but mostly we will take -2. Algebraic sum of all the oxidation numbers of all the atoms in a neutral molecule will always be 0. Like if there is water, for example, if water is there, so here oxygen is having -2 oxidation number and hydrogen is +1 into 2, that is +2. So +2 -2 will be equal to 0. So this is the oxidation number of a molecule, or sum of the oxidation number of all the atoms in a neutral molecule will be equal to 0. Algebraic sum of oxidation numbers of all the atoms in an ion will be equal to the charge on that ion. Likewise, we can take any other example like sulfate, SO4 2 negative. Here oxygen is 4 2s are 8 -8, okay, and sulfur is having +6 here oxidation number. So if you calculate it, you will get -2. So the sum of all the oxidation numbers in an ion will be equal to the charge on that ion. Next is, now let's solve a few examples based on the above rules that we have discussed. Suppose you have been given H2SO4 and the underlined element, the oxidation number of which you have to determine is sulfur. So how we will solve? Firstly, hydrogen oxidation number here we will take +1. So +1, and there are 2 hydrogen atoms, so we will multiply it by 2 plus. Sulfur will take the oxidation number of sulfur as we have to find it, so we will assume it at X. Next, plus oxidation number of oxygen will be here taken as -2, and there are 4 atoms of oxygen, so we will multiply it by 4. Now solve it. We will get 2 1s are 2 plus 2 plus X plus 4 2s are 8, that is -8. So here we write -8 equal to +2 plus X and here it will be equal to 0 because it is a neutral molecule. Minus 8 is equal to 0, equal to minus 6 plus x is equal to 0, and x will have the value as plus 6. So here the oxidation number of sulfur will be plus 6. Now another example, potassium dichromate. Here we have to find the oxidation number of chromium. So again this is a alkali metal, so we'll take its oxidation number as plus 1 into 2 plus. Here we will assume again chromium oxidation number is x, and there are 2 atoms, so we will write it as 2x plus minus 2 for oxygen atom, and there are 7 atoms, so multiplied by 7 is equal to 0 because it is again a neutral molecule. So here we'll get plus 2 plus 2x minus 14 is equal to 0. 2x minus 12 is equal to 0, and 2x is equal to plus 12. X will be equal to 12 divided by 2, that is plus 6. So again here the chromium oxidation number will be plus 6 in potassium dichromate. Another example is sodium thiosulfate, where you have to find oxidation number of sulfur. So this is again an alkali metal, so we will take the oxidation number as plus 1 into 2 plus. Sulfur will assume it as x, and there are 2 atoms, so 2x plus. Oxygen minus 2 into 3, that is minus 6. Again equal to 0 because it is a neutral molecule. Now solve it further. Plus 2 plus 2x minus 6 is equal to 0. So we'll get here 2x minus 4 is equal to 0. That is 2x is equal to plus 4, and x will get, you will get the value of x as plus 2. Okay. So here the oxidation number of sulfur will be plus 2. Okay, so this is the oxidation number of sulfur in thiosulfate. Now we'll take an ion in which we have to find the oxidation number of phosphorus. So again we will assume it as x plus. Oxidation number of oxygen is minus 2 into 4 equal to minus 3, because here the charge on the ion is minus 3. So we'll solve it. X minus 8 is equal to minus 3. X will be equal to 8 minus 3, that will be equal to plus 5. So here the phosphorus oxidation number in phosphate ion is plus 5. Now next come to a complex ion, cobalt and ammonium. Ammonia is written in brackets, and there are 6 molecules of ammonia here, and the 3 positive charge are present on the ion. So how we will calculate the charge of cobalt in this complex ion? Again we will take cobalt oxidation number as x, and plus ammonia is a molecule, so its oxidation number will be 0. So we will write 0 into 6 equal to plus 3. So x, 6 zeros are 0 obviously, so x is equal to plus 3. So here the value of oxidation number of cobalt is plus 3. In this way we can find out the oxidation number of different atoms and different compounds. They may have different a single atom may have different oxidation numbers in different molecules. We will solve few more questions which has been asked in various competitions related to this topic. This is a very important topic which is very frequently asked in NEET as well as the engineering exams. So we will solve few questions in a different video where I will deal with all the competition based questions which are based on the same topic. Thank you.